Hello students, welcome to IMS GATE Academy, and we are discussing the foundation course of engineering mechanics part second chapter part 3, that is equilibrium of forces. Okay, so as you know that myself I am Dr. Vijaya Kumar. I am going to teach foundation course of engineering mechanics equilibrium of forces part 3. Okay, now let us go to the topic. Guys, last class we had been discussed about equilibrium of forces, and we have seen some cases, right? Now in this session, so we will see some other cases of equilibrium. Suppose say if the bodies are given see, last class we had seen that one flat surface contact with another another flat surface, how to solve the problem and how to solve the reactions we have seen. Similarly, if a curved surface is contact with a flat surface also, we have solved some problems. Okay, right? Now here today we are going to see that two curved surfaces are contact with two flat surfaces, then how to find out the reactions, and we were going to discuss all these things. Yeah, hope you understand. Before going to that, we will see one small concept that, and after that we will move forward for the next case. Okay, now to a small concept. The concept is that shifting a force to a point other than its line of action. Okay? Shifting a force a point other than its line of action. Okay, right. That it's for the small concept. So with the help of one example also, yes, okay, a force other than its line of other than its line of action. So hope you understand. Now let us go for. So I am taking one body, taking one at I am taking one body. Okay, on this body, a force is going to be acted. Okay, so now suppose that force act or here act or F, and its the point of contact is A. Right now, I wanted to shift this force on the body point B. What my objective? Okay, so what I'm trying to explain you guys here, see that one body I'm considering, and on this body a force is acting at point A. Right now, this force I would like to shift to point B. How to shift the force? Okay, now see, suppose say that this is the line of action of the force F. Line of action of the force. Now I wanted to shift over here. Now for this case, what I'm supposed to do now? It's a very simple. Again, I'm taking a body. Again, I'm same body. Right. Now my force is a force, and this is now at point B. What I do now? So I just use two forces which are having the equal in magnitude and opposite in direction at B. That is force also. Why? Because here, so two equivalent magnitude and opposite direction forces are used. So there will be a no effect. There will be a no effect is created on this body. That means, so whichever the effect it is having, that without changing that effect, if I use any two forces which are equal in magnitude and opposite in direction, that we can take anywhere. Okay. Now this is the point. Okay. Now see, this is the or line of action of line of action of a force, right? Now on the same body at B, I use two forces which are equal in magnitude and opposite in direction, right? Now see, these are the line of right. Now here, guys, what happened now? Now below our perpendicular send it, guys. Right now, see these F force and these F force which are having equal in magnitude and opposite in direction and are separated by a definite distance. Then what happened? These are going to create a couple, na? So couple moment. I have explained you couple moment. So two equal in magnitude and opposite in direction forces parallel to each other and separated by a definite distance. Then what happened, na? So those are going to be created a couple moment. Now here also, see here also this F force and this F force, these F force are going to create couple moment. So that in place of this force, I can create a couple over here. Now I will show you in the next page. And here I'll a couple. Right? Okay. Now very simple, guys. See, so in place of F and F are separated by a definite distance, that they are going to be created a couple. Okay, they are going to be created a couple, and I'll couple. So that I just remove these this force and I replace a couple over here. So that I can replace my F force from point A to the point B, which are not its in line of action of force. Okay, I hope everybody understand how to shift the force from a point other than its line of action. Okay, as we know that already, so we can use this force anywhere along this line of action. But the thing is here, what I'm trying to tell you, this force has to shift other than its line of action. For that, what we have to do now, so you just use two magnitude, whatever the magnitude this F force is having, similar magnitude forces and which are opposite in direction, you use here and then replace with a couple, so that your force will be shifted from A point to B point. Okay, so I hope everybody understand how to replace this force. Clear, everybody, guys? So I will show you one example as well. Okay, right. We will see one example also. Example for shifting the force. Example for shifting the force. Now let us assume that a small question, guys. a 10 Newton force acting on this beam like this. 10 Newton force acting like this. Now this distance, one meter, and right now I want to shift my force 10 Newton. I want to shift my force 10 Newton here. What I'm supposed to do? What I'm supposed to do now? Here, as we know that 1 meter. For shifting this force to here, then I am supposed to use Newton force upward direction, also 10 Newton downward direction. Isn't it, guys? 10 Newton force acting upward direction, 10 Newton force acting downwards, so that there will be a no change in the effect of this body or this beam. Clear, everybody, guys? Okay. Now here, see what happened. This 10 Newton upward 10 Newton load and downward 10 Newton load, so are going to be separated by a definite distance and are parallel. So that is why these are going to be created a moment. These are going to be created a couple moment. This upward force 10 Newton, downward force 10 Newton are separated by a definite perpendicular distance, that is 1 meter. That is the reason why these are going to be created a couple moment. So that finally, how can I draw my beam? I can draw my beam like this. I just, now its moment is 10 Newton. And 1, this couple is 1. Why? Because couple moment is force into distance. Force is 10 Newton and 1 meter. 1 into 1 meter. So 1 into 10 into 1 meter. So that this. So my 10 force is shifted to here. Actually, put the line of action, right? Other than the line of action, this force for here. And with the help of this, I hope everybody understand what the concept we have discussed earlier. Same, I am going to explain you with the help of one simple example. So 10 Newton load is acting over here. I want to shift this load or this 10 Newton load here, right? Like to, for that case, what I did. So two forces which are equal in magnitude and opposite direction forces are applied, and upward force and downward force create momentum. So that is why what happened now, this 10 Newtons load and momentum I created, I shifted my 10 force or here. Okay, hope you understand. I hope I have simplified shifting the force other than its line of contact with this example. Hope you understand, everybody. Please do respond, guys. Thank you very much. Right, now let us go for another concept. Next is a curved surface in contact with the another curved surface. Okay, if two bodies are in curved in nature, if they are in contact, how to solve this reactions. That means by considering the equilibrium case and how to solve the reactions, that I am going to explain you. Okay, right. A curved surface, case 3, I guess. Last class we had been discussed 2 cases now, and this is the third case. Curved surface. Curved surface. All right. Now let us here this case we will see the help of one example. So we will see this case with a one example. Yes, guys. Now here for this so these are the two curved surfaces, and these are the two curved surfaces or now here see guys, two curved surface contact with the other another two another sorry a curved surface contact with the another curved surface. Okay. Now here see that these are the two balls, so which are having certain weight, and these are contact with this here. Okay, right. Now it is make an angle of 30 degrees over here. Is make an angle. Okay. Now say this ball A, ball B. Now ball A 8, ball A and ball B are having one. Now radius of RA, radius of equal to a taking. Okay. Now see guys here, so where the contacts are there. Okay. Now this ball is contacting over here. This is I am taking contact 1. Okay, and say this is the contact 2, right? Now this is a contact 3. Okay. Now this is contact 4. Okay. So 4 contacts are there. So 4 contacts are there, right? Now what's your question is? What's your question is? Find reaction. Find the reaction at at 1, comma and 4. Okay, what your two weights are given, and also this make an angle, this inclined surface, the balls are overweighing here. Now we need to find out the reaction at contact 1, contact 2, contact 3 and contact 4. This is what the question. Okay, right. So whenever two curved surfaces are contact with each other, then how to solve the problem and how to find out the reaction, that is what I am going to explain you. Here everybody guys, hope you understand, right? Right. Now let us see that how to see. If you observe that 1, 4 or contact with a 1, 2, 4 or contact with a flat surface. 1, 2, 4 or contact with a flat surface, right? Now 3 is contact with a curved surface, isn't it guys? 3 is contact with a curved surface, right? Now first we will draw the free body diagram of B, and then we will find the R3, R4 and R3, and then we will come over here and find R1 and R2 as well. Okay, right. Now let us see guys. If suppose if I remove this vertical plane, then what happen? My reaction will act like this R1, right? If I remove this, now my reaction force R2 exactly perpendicular to the surface, it is going to be act like this. Okay, now my reaction act like, okay, that that act right. Similarly, if I remove this flat surface, if I remove this exactly perpendicular, my R4 is act. My R4 is be act. Right. Now here R3 act on body like this and onto this body. Okay. Both are R3 only. Again, so I just highlight that 100 Newton and also, right. Now let us draw the free body diagram of this. Okay. Right. Now if now find out this angle R4 with horizontal, how much it is make an angle. So this is perpendicular, okay, perpendicular, and take this triangle, and it is a perpendicular. Then it guys, take this triangle, it is a perpendicular, 30 and it is a 90. Then what happened to this? Obviously it is going to be a, okay, how we got that? So by taking the triangle, so if I take 0, 0, 4 and you take this a 5, 0, 4, 5 triangle. So in that perpendicular, so this is 30, so that 180 minus 90 plus 30, so that I am going to get it is a 60 degrees. Hope you understand everybody. Okay, right. Now draw the free body diagram of this. Okay, B. Body diagram of R. PD of R. Got not R. Now let us take that. Uh, or what's this reaction? R4. R4. Similarly, R3. So R3, how much its angle? Okay, R3 angle. Determine the angle, how much it is make an angle with a horizontal. That is very, okay, right. Now for that I draw the line of action of this fellow. and like, so that it make 30 degrees to the horizontal. Okay, so this is R3 also make an angle 30 degrees to the horizontal, right? Now my R3. Now weight of the body acting downward, right? Okay. Now, so see guys, if you properly observe this, we have a R4 and R3 and this one, and we know the angles. How much R3 make an angle with the horizontal? How much R4 can make an angle with the horizontal? We know. So that here three unknowns, two unknowns. Can we go with the Lamis theorem? Obviously, can go for the Lamis theorem, right? Now, let me separate this. R4 and its degree, R3 30 degree, and weight of the body downward, isn't it? Right? Now, for finding the Lamis theorem, what we supposed to do? We need to find out the angle between the forces. That is what we have discussed yesterday. Na? So, what is Lamis theorem states that, so the ratio of any force to the sine of the sine angle of rest of the two forces, right? Now sine angle between the rest of the two forces, that is what the Lamis theorem, right? Now let's decide that angles between them, this is 60 and so that this is 30, so 30 and 90 degrees. Okay. Now next is, how about this angle? How about this? Yeah, right. How about this 30, 30, 30 plus, right? Now plot the so apply Lamis theorem over here. Apply Lamis theorem. How can we write, right? First is R4 divided by sine angle, sine 120. It Early it is equal to R3 divided by, so sine 150 equal to, it's gonna be 100 is divided by sine, right? What the Lamis theorem, right? We require R3 and R4. One time you equate R4 by 1 sine 120 equal to 100 divided by sine 90, so that you will get R4. Similarly, you just do that, R3 by sine 150 is equal to 100 by sine 90 if you do that, so that you are going to get R3 and R4 reactions. Hope you understand, guys. Okay, now let us solve that quick. Now here, first I'll take that directly. I'm writing R4 equal to a 100 sine 120 degrees divided by sine 90. Right? Now, if you solve this, then you're going to get it is, let me know what is R4, guys. What is R4? 86.60 newtons will come. 86 newtons come. Hope you understand, everybody. Right? Next. Similarly, R3. R3 equal to, it is sine 150, 100 sine 150 by sine 90. 100 sine by that, I'm going to get my R3 is equal to, let calculate and help me know. So I'm going to get it is 50 newtons. Yes, guys, clear, everybody? Now let us go for free body diagram of A. So with the help of taking only free body diagram of B, and I found that reaction 4 and reaction 3. Now I know reaction 3 and reaction 4, reaction 2 or reaction 1, I don't know, reaction 2, I don't know. So by using this, it is possible to find out next one. Okay, right, guys. All right. Now let us go for draw the free body diagram of A. Now body diagram of A. Now here, as we know that W is 100 newtons. Yes, guys, W is 100 newtons. Now reaction 1. Okay. Right. Now let us go back and reaction 2. Now here we have to decide that how angle it is making. Obviously, see here it is 9 and it is a 30. So that this is also going to be a, okay, right. So R2 make an angle with a horizontal 6 degrees. Okay, like that you are supposed to solve. Okay, right. You remember, guys. Now here I R2 reaction come 600. Right. Now 1 R2. Right. Now, so we have to place R3 reaction also, because if I remove this ball, then the reaction on the ball is acting on this particular ball A. So ball B, if we remove, then some impact, some reaction force is going to be act. Right. Now let us see that where we have to see. For that, taking a, okay, I'll show you that. Now from here, action R3 is action acting on this ball. Now its line action is. Now R3 makes an angle with the horizontal how much here? With the horizontal how much here? Right. We have already decided now R3 make an angle 30 degrees to the horizontal. Okay, right. So, sir, here you have taken it is R3 is acting on the B. Now you are taking R3 is onto the A. Now see, whenever I consider B, then by this A ball, some reaction acting on the B ball. Okay. Whenever I am considering A ball, then some reaction from the B acting downwards on this. However, the magnitude of R3 is same. But whenever you draw the separate free body diagrams, then what happen now? This fellow is comes into picture. Okay. Now you can also, but whenever you are considering ball A only, then you need to do this. Okay. Hope you understand, everybody, guys. Hope you understand. Right. Now let us go. Draw the free body diagram. Draw the free body diagram. Okay. Right. Now the first case R1 acting. Now here R2 make this, right. Now R3 acting toward frontal, right. Now weight of the ball acting, right. So how many unknowns? Two unknowns, R1 and R2 are the unknowns. However, we know R3 and however we know 100 newtons of the ball. Okay, right. Now this is right. Now, so do we possible to apply Lami's theorem over here, guys? Is it possible to apply Lami's theorem over here? No, not possible, because here four forces are acting: R1, R2, R3, and also weight of the ball. But according to the Lami's theorem, what happened? Three concurrent forces, so which are towards or away from the body. Okay, so which are towards or away from the body, then only it is possible to apply the Lami's theorem. but here 4 forces are there, R1, R2, R3 and 100 newtons. So it is not possible to apply Lami's theorem. Then what to do? Then what to do? Then what to do? Right? Now here we need to apply equilibrium equation. Very simple. Okay, right. I'll write this statement as well. Here Lami's theorem not works. Here Lami's theorem not work. Not works. Yes, guys, and everybody. Here Lami's theorem not works. Then what we should do? Right. Now here to resolve the forces. So if Lami's theorem not works, then sigma fx equal to 0 or sigma fy equal to 0 or moment about any point equal to 0. It is not possible to take moments over here. So however, by using the combined free body diagrams, we can use the moment about any point equal to 0. Okay. Now here guys, see here resolve the forces horizontally and vertically. Right. Now here R2 cos 60. Here it is R2 and it. Now here this R3 cos 60. Right. Now here R3 sin 60. Yes, guys. Right. Now take sigma fx equal to 0. Take sigma fx equal to 0. Yes, guys. All right. Now let us go for take sigma fx, apply equilibrium. I right. Yeah. What is that? First one is first we'll take that right here forward direction. Right. Now see that what are the forward forces? What are the forward forces? See R1 forward direction. So R2 cos 60, R3 cos 60 or this direction, right? This is R1 is a plus and R2 cos 60 and R3 cos 60 or the negative, right? Now let us for here at R1 R2 cos 60 cos 60 0. Then it guys, right? Now from here you just let's say that it is equation number 1, that is R1 R2 is R3 cos 60 for 1. What do you say guys? For 1, right? Now similarly apply my fy equal to my fy equal to y equal to upward then. Yes guys, right. Now here what are the upward forces here? See upward forces, downward forces. So R2 sin 60 upward and R3 sin 60 and 100 newtons are downward. So this is positive. R2 sin 60 is the positive and R3 sin 60 and 100 are the negative. Isn't it guys? Right. Now let us write that. here R2 minus R3 minus 100 is equal to 0, right? As we know that R3 na, R3 we know how much we got R3, 50 newtons, right? Substitute that here R2 equal to gonna be a T minus and sorry plus 100, isn't it, right? Now here R2 I can write it as, I'll go for the next stage. Right, it is red by that R2 equal to, no, R2 is equal to, it is 144.8, right? Now go back to this, as we know that R2 we know, R3 we know. So then substitute these values and get the R1. Now here I'll write from equal 1 from 1 that 1 is equal to R2 plus R3 plus, now my R2 I got that 144 point plus E into cos 6. All right. Now here R1 I am going to get 115.47. Clear, everybody, guys? Clear? Right? So like that you are supposed to solve the problem. Like that you are supposed to solve the problem, right? Now I hope I have simplified that. I have simplified that if two curved surfaces are given and which are resting on the floors, then how to solve the reactions. How to solve the reactions I have shown with the help of examples. Ball A and ball B separately you take a free body diagram of B and solve R3 and R4 and R3 similarly, and by taking the free body diagram of A and solve the R1 and R2. Okay. So in gate question what happen are these kind of lengthy questions they won't ask. Okay. They ask you that only one reaction out of R1, R2, R3, R4. So any one reaction they may ask that R1, they may ask R2 and they may ask that R2, R3 and R4. Any one they may ask. Suppose let us consider that they ask you to calculate, if they ask you to calculate, so suppose if they ask you to calculate R4, they suppose ask you to calculate R4. In that case what happen na, combined free body diagram you have to consider. Combined free body diagram you have to consider, guys. Okay. Now let me show you how to use this combined free body diagram. Okay. Now combined free body diagram of A and B. Find of find free body diagram of A and, yes guys, combined free body diagram of A and B. Okay. Now let us see that how to do this. right? Now this is my ball A. Ball B. Now in the combined free body diagram, how to take that? Okay, right. Now see here, guys. Now this is my reaction R1 as we know. Okay, my R2, right? Now here R3. Why? However, I'll show you R3. Now here R4. Now similarly, weight of the body downward 100 newtons. Body downward, right? Yes, guys. Okay, right. Now in that case, what happened now? So now here I'm taking center is A and is I just remove those. Now here A and B. Now here as we know that this radius we know, this radius we know. How much this radius and this radius, guys? Right. This radius is 100. This radius is 100. So and this is now this is what the combined free body diagram. Okay, this is the combined body. Yes. So from here we need to find out the R4. From here we need to find out the R4. Yes, yes, yes. Now, so for finding R4, here you can apply equilibrium equation now. So here we can apply which equilibrium equation we are supposed to apply to, whether if you go for sigma fx equal to 0, sigma fi equal to 0, or moment about any point equal to 0. You can take any one of that. Okay, but the thing is here, depending upon your requirement, you need to find R4. You need to find R4. So accordingly, you are supposed to select your this one. Yes, guys. Yes, please do respond. Do respond, guys. Right. Now here taking moments about A. Taking moments about A. About A. Taking moment about A, MA equal to, yes, guys. Clear? Clear, everybody? Right. Now see, if I take moment about A, then moment created by R1 equal to 0, moment created by R2 equal to 0, moment created by this 100 Newton also equal to 0. Why? Because all these are passing through the point A. That is why here moment created by these forces are going to be 0. So here R3 is also creating 0 moment, right? Now only this force creating. And okay, now if I fix this point, and if I apply R4, then it tries to rotate the body anti-clockwise. Yes, guys. So if I fix this body, if I fix this A point, if I apply load here, if I apply force here, then it tries to rotate the body anti-clockwise. Yes, guys. Right. Now here I can write my moment here R4 the negative, right? Minus R4 into perpendicular distance. How much perpendicular distance? So this is your perpendicular, right? Your perpendicular distance, RA, and this is RB, right? Now 100 plus 100, 100 plus 100, right? Now next, if I fix this point and if I apply force over here, then what happened? So this 100 newtons try to rotate the body clockwise. So this A point I fix, if I apply load over here, then it tries to rotate the body clockwise direction, right? Now 100 newtons into perpendicular distance. Yes, 100 newtons to perpendicular distance. Where is my perpendicular? That is a question over here, right? Now here this perpendicular distance I require. Yes, guys. Right? 100 newtons into perpendicular distance. R4 into perpendicular distance. That is what moments about A equal to 0. That is what we have considered. Yes, please. Yes, guys. Right. Now, how to find this? Right. So, plot a small triangle. Plot a small triangle. Right. Triangle. So, A point is B and this point say, suppose say that, right. As we know that this is a, right. And what is this distance? 2R. Yes, 2R. A to B distance is 2R na. A to B distance is 2R. What your 2R. Yes, guys. A to B distance is 2R. Right. Now I require this distance say X. I require this distance say right. Now, so can I use this here cos 30? Cos 30 equal to X by 2R. Right. Now X equal to R 2R cos 2R cos 30. Right. Now this is my X. Right. Now here I can write directly 2R cos 30 equal to 0. 2R cos 30 equal to 0. Yes, guys. Now everything I know. Everything I know. Right. Now here let us go for the next step. I'll write the next step. Moment about equal to 0. Right. Oh my God. R4 mid S mid in R cos 30 equal to 0. Moments about A equal to 0. Why? Because here, so R4 moment, R2 moment and also R3 moment are 0. Why? Because they are passing through the point A. Right. Now, only moment created, if I take moments about A, only created moment is 100, this 100 newtons and also this R4. Now, if I fix this point, if I apply R4 such that it is going to be rotated anti-clockwise. That is why clockwise we have taken positive, anti-clockwise we have taken negative. Right. Now, minus R4 into perpendicular distance is 2R. R is 100, so that 200. Next, if I fix this point, if I apply load over here, this fellow try to rotate the body in clockwise direction. That is why it is plus and 100 into this perpendicular distance. This perpendicular distance I have calculated by using the triangle like this. As we know that this is a 30 degrees, na? So this is 30 degrees, right? So from the 30 degrees triangle, I have found that X, I got that 2R cos 30. So 100 into 2R cos 30 is the perpendicular distance, right, guys? Now here, just simply we can solve this one in a very easy way. Now here I can write it is R4 100 into R is 100 to cos 30. Like that I can write, right? Now here R4 is equal to, right, it is 100 into 100 cos 30 divided by 100, I can write. Now find the R4. So you will get the same answer what we have done in the previous case. R4, you are going to get it is 86 point. So, clear everybody, guys? Clear everybody? Like that, you are supposed to solve your particular C. So if they ask only R4, then take a combined free body diagram and then you take moments about any point equal to 0 and then you are going to get R4 very easily. Clear? So hope you understand, everybody. Okay, I hope I have simplified. So how to solve the problem when two curved surfaces are given. Right, guys. Right. Now let us go for solve one question. Now let us have a look on this problem, guys. Similar problem. Try to solve this. I'll give you 1 minute time, and here say that some letters are not visible. Contact point is A. Okay, the ball one and ball. You try, guys. I'll give you 1 minute. You try, and I'll solve. Right. Now let me read the question. Two identical rollers of weight 445 newtons and supported by an inclined plane on a vertical wall as shown in the figure. Assume smooth surface and reaction induced at point A. Okay. Now here, guys, I just highlight that where it is properly. Are the two balls, sorry, two rollers. Now two rollers are given, right? Now which of each of weight 445 newtons. That means this weight is also 445 newtons. This weight also 445 newtons, right? And these are no or supported by a inclined plane like this. Inclined plane like this, right? Now as shown in the figure, it is a surface reaction at A, right? Now here find no reaction at what we need to find. This point is A. Reaction at A we need to find, guys. Okay, right. Now if I take this fellow reaction RB, now say reaction is right. Now this is also make an angle degrees to the horizontal. also make an angle 60 degrees to the horizontal as we know. Okay. So now here and its weight 445 newtons and its weight also 445 tons. Done it, guys. Right. Now let us see that. Let us draw that, you know. Let's apply sigma Fy equal to, let's apply sigma, right. Now what are the upward forces? RB cos 30, right, upward forces na, RB sin 30, RC sin 30, sorry, sin 60, here 60 na, with the horizontal, right. Now here RE S RC minus downward forces. Downward forces are 445 minus 445 is equal to 0. Right. From here I can write it is RB plus RC sin 60 equal to, is gonna be a 2 into 445. Right. Now I'll simplify my equation. RB plus RC equal to 5 by per 1. Okay. Similarly, you apply sigma Fx equal to 0. Right. Right. Sigma Fx equal to 0. Right. What are the forward forces? RA forward. Now RB cos 60, RC cos 60 or this side. Okay. Right. Now your forward forces are now here sigma Fx equal to, right, sigma equal to 0, then is RA minus RB cos 60 RC cos 60 equal to 0. Right. From here I can write my RA is equal to RA RB, no, is gonna be a cos 60. I'm going to, right. Now here if we solve this, then you are going to get RA plus RB na, RB plus RC you are going to get na. So here it is RB plus RC. As RC, isn't it, guys? Right. Now here, so RA equal to this much. Now here if I solve this, all the numerical values only na. Now I am going to get it is 1027.68. Point I am going to get. Now substitute this value over here. Now here RA equal to 0.6 cos 60. Now if we solve this RA, you are going to get it is 513.8. 134 Newton. Yes, guys, like that you are supposed to solve. Okay, so I apply two equilibrium equations. Sigma Fx equal to I have taken, sigma Fy equal to I have taken. So accordingly, you are supposed to solve the problem. Yes, guys, understood? Now let's go for another question. Have a look on this question. It's also similar. I'm just making you perfect. I'm just making you perfect when two curved surfaces are contact with another two flat surfaces, how to solve the reactions. That is what I'm going to solve. So I have explained that concept and I'm solving the example problems as well. Yes, guys, right. Now try to read this problem and try to solve. Now let me solve myself, guys. I hope this all, it's only one step problem. Properly understand, then it will be very easy question. Right now, two spheres A and B are 100 newtons and 75 newtons respectively. Okay, so two spheres are there. A sphere weight is 100 newtons, B sphere weight is 75 newtons respectively, with a corresponding radius of 75 mm and 50 mm. So this is having 75 mm, having 50 mm radius, okay, or placed in a container shown in the figure. Determine the support reaction at S. Okay, determine the support reaction at S. Okay, guys. Now this is your, at this point you need to find out the support reaction. Now, so can I write it is or yes? Can I write it is or yes, guys? Can I write it is or yes? Two spheres A and B. Now, yeah. So here, guys, weight of the A sphere is given, weight of B sphere is given, and radius of A sphere is given, radius of B sphere is given. Now we need to find reaction at the point of yes. We need to find this one. Yes, clear everybody, guys? I hope understand. I hope you understand everybody. Right now here, what I'm trying to explain you, though you're drawing the individual phase diagrams of A, individual phase. I'm sorry. Individual free body diagram of A, individual free body diagram of B. Then so it is takes more time. Right. So because only we have to calculate only one reaction, RS reaction, right? Now in this type of cases, you have to go with a combined free body diagram, So now let me explain you what is that combined. So we have already solved that. Okay, right. Now let us go for see that combined free body diagram. Now you guys saw here WA is given how much? WA is given how much? It is 100 Newton. Is 100 Newton. WB is given, that is how much? 25 Newton. 5 Newton. So it is 100 Newton and it is 75 Newton. Yes, guys. Okay. Right. Now, if I remove this plate, that means vertical plane. Then what I'm going to get here? I'm going to get it is RL. Here I'm going to get RL. Now, if I remove this, I'm going to get here reaction M. Reaction at M. Right. Now, similarly, if I remove bottom, if I remove bottom, then I am going to get reaction here. I'll show you. And now here is RS and to get right. So here I require RS. Here I require RS. Right. Now RS is going to be act like this now, upward direction. So here it is quite clumsy. That is why I place RS over here. Okay. Now here you no need to draw this. Draw this. Right, guys? Clear, everybody? Right. Now here, how simple we can draw this. How simple we can draw this. See, if I apply sigma Fy equal to 0, then I can get directly RS na. So combined free body diagram of A, okay, A and B. So here if I apply sigma Fy equal to 0, then what happen? Upward forces minus downward forces equal to 0, right? Now let us apply that. So sigma Fy equal to 0. That I am going to get here in a very simple equation. That is, RS the upward force. RS is the upward force, downward force. 100 minus 100 minus 75. Right? Equal to, now here RS is equal to is 100 plus 5. That RS is gonna be a reaction at S point 175 tons. Clear, everybody, guys? Okay. Now, so the problem, see, whenever you look into the problem, so because of these diagrams, you may get scared. But don't worry. If you are properly, if you are having the strong in basic knowledge, then it would be very, very easy to solve this kind of question. Okay. So I hope everybody understand. Now let us go for another question. Right. Have a look on this question. Have a look on this question, guys. Right. Now, so please, I'll be back in a minute. Yes, guys, it is solved. What we need to find. Now let me read the question. Three cables are joined, not or, here you guys. Cables are joined at the junction ring C, right? So three cables are joined at junction ring C. Determine the tension in the cable AC. Determine the tension in the cable AC, okay, caused by the weight of 30 kg cylinder. 30 kg cylinder. Use G equal to 10 meter per second square. Okay. Now what we need to find, guys? What we need to find? Tension in the AC. Okay. This cable. Okay. So this cable. So these are all fixed. Okay. Now here T, tension in AC cable. Okay. Tension in AC cable. How you need to find. Okay. Right. Now it is a 30 kg weight, and so because of this, some tension is going to be created in AC cable that we need to calculate. Okay, that we need to calculate. Clear everybody, guys? Clear everybody? Hope you understand. Hope you understand. Right, now let us move for, let us move for, first you consider that, so block of weight is acting downward, right, 30 kg acting downward. Okay, right. Now here, so some tension is going to be created in TDE. What do you say, guys? Okay, what do you say, guys? Right. So now this tension in the cable of DA is equal to 30 kg, isn't it? Yes, yes or no? Consider equilibrium of cylinder. Okay, so consider equilibrium of cylinder of, right. Now here I'm just taking the cylinder, right. Now here your T tension in DE cable, right. Now weight is acting downward, that is going to be a 30 kg, right. This is into G, 9.81. So that they are asking that to consider 10, right. Now, so by applying a sigma Fi equal to 0, how can I write? How can I write? Now let me write that minus, right, 30 is 10 is equal to 0. That I can write TE equal to a 100 newtons. Going to be a 300 newtons. Clear everybody, guys? Clear everybody? Right. Now I hope everybody understood. Now here, guys, if you observe that properly, so whatever the tension here created TDE, the same tension in the TC also. 1 minute. Same tension in the TDC also. Okay. Also having same tension. So here I can write it is tension in L. Okay. Hope you understand, everybody. Hope you understand, everybody. Now you take that equilibrium case of at C. So take the equilibrium at C, right. What is the tension in this here? It's gonna be a T BC, right. Now here, this is a tension is going to be happen like this. If I consider over here, the tension is going to be act like this. If I consider over here, the tension is going to be like acting like this. Okay, so hope you understand. Hope you understand, guys. Okay, right. Now here, so if I consider this point C ring as a center point and consider as a equilibrium, then so what happen now? Again consider equilibrium at junction C. Okay, so consider equilibrium at junction C such that tension in AC will go on this time and tension in BC will go on this time, tension in DC will go on this time. And so do remember, guys, TDE equal to TDC. So whenever you consider this block, the tension is going to be act upward. So whenever you consider at C ring as a equilibrium, then the tension is going to be act on this direction, right. Now let us draw that also. Consider equilibrium at consider equilibrium at yes, guys, right. Now here I would like to draw this. Now this is point. Now what is this? EAC, EBC. Now this is EBC. Now this directly, right. Now let's decide the angles over here, right. Now if it is a 45, draw this 45 degrees and this will also 45, right. Now so is 30, this fellow is 30, obviously also 30, right? So the horizontal it is make an angle 45 degrees, right? Now let us see, go back to our problem. Now here I just draw the right. Here can we apply Lamis theorem, guys? Here can we apply Lamis theorem? Here can we apply Lamis theorem? Yes. So for applying Lamis theorem, we need to decide the angles between them. We need to decide the angle between the tensions. Right. Now let's decide that. So this is 45. So this 45. Now 30. So this is just 45. Okay. 5 degrees. Okay. Right. Next 45. 15 is gone. So 90 minus 15, 75. 75 plus 45, 80 and 120. It's now after that gonna be a 50 plus 90. 15 plus 90, 105. 105 plus 30, it is 5. Right. Now let's write Lamis theorem and find out that particular one. Right. Now let us write that EAC divided by you know sine 145. Sine by this. Okay. EAC is equal to this much. Next T divided by sine 120. Right. Now T divided by sine 105 sine 105 degree. Yes, guys. Right. Now what they ask you, tension in the AC. That is why TDE you know na 300 newtons, right? So now TDE you know. Now you take these two terms, and then solve that, right? Now here let me write that equation. AC divided by sine 145 equal to divided by sine 105 degree. Now from here, how can we do that? Now we know that TD equal to yeah, 100 Newton, right? Now let us substitute that AC equal to sine 45 degree divided by sine 5 degree. Now solve that, then you are going to get your EAC guys. Here we have done mistake, small mistake, that it is a 105 and it is a 35. So it is 135. 135. Here also degree. Now here also yeah, right guys, if you solve that, then you are going to get it is approximately 20 tons you are going to get, right? Now, hope I have simplified this. Clear, everybody? Now, so guys, don't tense and panic when you look into the question, because of that ropes, dit ropes, and weights and rollers, pulleys. There's so many given in the problem, but don't panic about that. So whenever you have a confidence applying the equilibrium equations, that means see, sigma fx equal to 0, sigma fy equal to 0, and then moment about any point equal to 0. If you consider, and if you are very strong in drawing the free body diagrams, so that you will be very, very perfect in the equilibrium. Okay, so now this is what about the session of equilibrium of forces. Okay, I hope I have clarified all the cases. Okay, right. Now let us go for a small announcement for you guys. Right. So these are the IMS gate aspirants for 2023, guys. So these are our toppers. Okay. Now if you look into these figures, see here so many ranks below 20, below 20. See ME All India rank, third rank ME, and All India rank in information implementation, All India rank 4 in CSE, All India rank 4 in production and industrial engineering, All India rank in ES, and All India rank in mechanical again, All India rank 7, All India rank 9 in mechanical, All India rank 10 in production engineering, and All India rank ECE, that is 17, and All India rank triple E 15, All India ranks 19 civil engineering. So all these are all our that means our students, and which were crack within 100, and they are securing their careers in a better way in the future. Okay, so they may go for PSU jobs, and they may go for the abroad studies, and they may go for the MTech in NIT or IIT. Obviously, in these ranks, they may go and settle down in the IIT itself. Hope you understand, everybody, guys. Okay, this is what our strength. Next, now what course features, what IMS offers to everybody. Now here, look into here, Gate Live Online. So we have a 3 modes of classes, that is we have a 3 modes of online 3 modes of coaching, that is online and hybrid model and offline classroom. Okay, so in hybrid model, 70% as online and 30% as offline you are going to get. Okay, now here, so if you join with us, if you enroll with us, then the course features are 800 plus hour live session, the live interaction. Okay, right. Now, and also 130 plus online test series. Okay, next 22 to 30 books, theory books and exercise books. In theory books, you are going to get conceptual explanation, examples, and exercise book. All the questions, level 1, level 2, level 3 are equipped with a very good logical questions, which are very frequent to GATE. So most of the questions are repeated from the GATE models. Okay, right? Exercise books, theory books are there. Also, next, 12 one-to-one personalized mentorship sessions are also provided. Though you are preparing very well, but unfortunately your confidence levels are less, in that case you may book the slot the faculty, and faculty enhance your confidence level with a good motivational speeches. Okay, so you may directly interact with the faculty. Now revision sessions and all more and more. Okay, now for you, so now it's your turn, and to acquire all these facilities, then you just freely call on us for Bangalore, Vijaya, and Nagpur, and Ahmedabad, and other cities. You may contact with these numbers, guys. All right. Now, for admissions, open classroom, online courses, GATE to target the GATE year of 24 and 25. For inquiry, please contact your nearest branch. Okay. So now IMS GATE Academy, and this is what the address: 3rd floor, Bank of India building, opposite to the modern supermarket, Pen Circle, Vijaya. And you may contact with these numbers also, so that our team will back you and guide you in such a way that to enroll with us. Okay. Now, thank you all of you for your patient listen, and thank you very much. And we have successfully completed 2 chapters. One is the force system and also equilibrium of the forces. The next session, and we are going to start about friction. So fundamentals of friction. So by this foundation course, you may get confidence in order to go for the gate sessions. Why? Because I'm teaching very basic things, right? So if you these basics, if you go for the coaching, so that you will be very easy to understand everything and solve every problem in a very easy way. Okay. So hope you understand. Thank you all of you. Thank you very much.